Okay, so the next two angle relationships that we're going to look at are adjacent angles and vertical angles. Adjacent angles, not super important if I'm being honest. Adjacent angles are just angles that share a common vertex and a side. So remember, when I say vertex, I mean like that middle point. So like B right there, that's the vertex. So angles that share a common vertex and a side. So adjacent angles could be something like, example would be angle A, B, E. A, B, E is adjacent to angle E, B, C. And angle EBC are adjacent. So they share that vertex of B, and then they share the side E. Those are adjacent angles. Adjacent angles they can be complementary. I think I'm going to spell complementary wrong. Let me double check. Yeah, I did. I put an I instead of an E. Complementary can be complementary or supplementary. So in most cases, you're not going to be looking like adjacent isn't going to be the relationship between them, because in most cases they're not only adjacent, but they're also complementary or supplementary. So like here, our example, angle B or ABE and EBC are not only adjacent, but they're also, and more importantly, supplementary. I'm just going to abbreviate supplementary there. So the fact that they're adjacent, that doesn't really tell us anything. That doesn't help us. But the fact that they're supplementary, that tells us that we can use that 180. So it's more important to realize about supplementary and complementary than it is adjacent. Now that's completely different from vertical angles. Vertical angles are important. Vertical angles are two angles on opposite sides of intersecting lines or razor segments, depending on whatever it is. So vertical angles have the same measurements and are congruent. Remember, congruent is like equal, the same. So vertical angles are equal, is what you want to be keeping in mind. Vertical angles are equal. That's what you want to have memorized about vertical angles. So when we say opposite sides of intersecting lines, rays, or segments, you can see here in my little diagram, I have two intersecting, I have an intersecting line and an intersecting line segment. So vertical angles in this example, and I'm going to use my highlighter here, vertical angles would be ABE, and then color DBC. Notice how they kind of form an X. They kind of like form an X. So, excuse me, I am sick after all. Okay, so specifically, angle ABE is congruent to angle DBC because they are vertical. There's also a different pair of vertical angles in there that you could get from looking at it the other way. And also angle ABD, right? ABD would be congruent or equal to which other angle? Which angle would be vertical directly like across from that one? And that would be the EBC on that other side there that I'm going to outline in blue. Boom. So, two different sets of vertical angles in this one diagram here. And again, I'm just going to continue that because vertical. So vertical is going to be helpful because you can create those equations by setting them equal to each other. So out of those two, vertical way more important than adjacent. We're going to take a look at some examples finally.